Hi guys, welcome to another lecture of Mtdm. Today we will discuss the thermal aspects of machining. That means the tool wear caused due to high temperature. So first of all, I will explain what is a tool wear. See, tool wear, the causes by which the cutting edge of the tool gets worn out is called as tool wear. That means, see, there are so many causes when the cutting edge becomes blunt. That means the opposite of sharp. So that is the main explanation to the tool wear. So we'll just say that the main reason behind the tool wear is temperature. See, temperature makes the metal soft or just decrease the strength of the metal. So the temperature can have effects on both tool and work. So on tool, these are the main effects. That means rapid tool wear, which reduces tool life, and cutting edge is plastically deformed. That means it cannot be changed or it cannot be regained, and tool may lose its hot hardness. Hot hardness means the hardness which is which is the property of the material, which can have a large amount of cutting forces during high temperature conditions. Okay, so that is hot hardness. And thermal flaking and fracturing. Flaking means the tool gets flaked apart. That means the layers of the tool material will go apart or worn apart, and that is also called as the fracturing of cutting edges. And the fourth one is built-up edge formation. That you already know what is built-up edge and how it is formed. The next one is the effects on work. See, when the tool gets blunt or the tool gets weird, the dimensional accuracy of the work will become very low. That means the blunt edge make the work to tear apart, or it lessen the accuracy in dimensions. And the next one is surface damage by oxidation. See, that is when the tool or excessively remove the metal, the surface of the workpiece will become exposed to so many corrosive conditions. So that will decrease the surface quality. And the third one is tensile residual stresses and micro cracks at the surface and subsurfaces. That means the residual stress that you have studied in material and metallurgy and materials engineering. The tensile residual stresses, when the tool is accurate in dimension and if there is no stress raises, the tool will be the workpiece will be perfectly usable. If the workpiece has some stress raises or invisible cracks formed due to the blunt edges of the tool, that it will decrease the it will increase the residual stress, which may become a factor for the complete failure of the workpiece. Okay, so now we will discuss the different tool wear mechanisms. That mechanism is the method by which the tool wear happens, or the causes of tool wear. So there are basically 6 different tool wear mechanisms. First one is diffusion wear, second one is adhesive wear. Actually it is adhesion wear. Okay, adhesion wear and abrasive wear. Abrasive wear is also called as abrasion wear. And fourth one is fatigue wear, and fifth one is shearing due to high temperature, and the sixth one is oxidation or chemical wear. Okay, so in these 6 different tool wear mechanisms, the main cause or the chief cause which play the main role is temperature. See, we will go through the details of diffusion wear. See, here you can see this is the figure for diffusion wear. See, diffusion wear is the movement of atoms through the lattice of one metal to another metal at high temperature. You know, it's a solid state diffusion. When two metal surfaces comes in contact in a semi-solid state, and the surface is at high temperature, the metal particles or metal atoms from one material will move to the next material. That is not at all appreciable while machining. So that is diffusion wear. Second is the adhesion wear. See, in adhesion wear, it is also due to high temperature. The soft metal see, the soft metal is basically meant of workpiece. The workpiece is called as soft metal, and the hard metal is the tool. And due to high temperature, the soft metal parts will adhere to the hard metal, that is to the tool, and becomes a welded like part. So that is highly inappreciable. So that is adhesion wear. You can see the adhesive particles. See here the small regions where the adhesion occurs. And now third one is abrasion wear. See, abrasion wear is it is the wear due to some particles from the same material. From the same material means from the tool material or workpiece material in contact, or foreign particles, that is in the terms of casting parts, we can see some sand particles adhere to the surface of the casting part, and that will that will increase the friction between the rubbing surfaces or the surfaces in contact, which increase the temperature, or which in terms reduce the strength of the material, and finally the tool get weared. The next one is fatigue wear. See, in fatigue wear, you can see some edges formed here due to the compressive force between tool and workpiece. We are giving a compressive force in tool so that we can machine the workpiece. But here you can see there are some edges formed here. See, these are the edges. While these edges are formed, high stress will occur at these points, and this is called as stress concentration. So that stress concentration will reduce the strength of the material at this edge, and which in turn will reduce the quality of the metal surface. So when it rubs in between, the edges will cut and it will form a straight surface. But under the action of pressure again to the workpiece by the machine tool, again these edges will form, and this in terms will form as cycles. Like first under compression there will be edges will be formed and it will be chipped off while the machining action, and again while applying compressive force there will be edges formed which is also cut off by the machining action, and this process continues to form many cycles, which in turn fail the material by the fatigue force formed in between the surfaces. So that is fatigue wear. And the next one is shearing due to high temperature. The simple mechanism is when temperature of a material or metal increases, at that elevated temperature the material becomes soft, so the hardness loses, and finally the material will fail. So that is shearing due to high temperature. And the sixth one is oxidation or chemical wear. See, it is just a theoretical explanation. Oxidation or chemical wear, you can see whenever a fresh machined surface is exposed to air, the oxygen in the air will comes in contact with the surface of the fresh metal, and this will form oxides. In case of iron or steel, when fresh material when becomes contact with the comes in contact with the air, it will form iron oxide. This is practically or chemically it is called as rust. So that will corrode the machine part. So it is not at all advisable for a high oxidation level, or it is also called as chemical wear. So there is a chemical reaction, that is oxygen plus fresh metal. The fresh metal gives an oxide, that is a chemical reaction, that is why it is called as chemical wear. So sixth one is oxidation or chemical wear. These are the main mechanisms which are which affects in the wearing of tools. So these are the main mechanisms. So you have to study all the 6 mechanisms and you have to reproduce in the exam paper. If the question is explain some of the mechanisms of tool wear. Now we will go to the next topic, that is types of tool wear. See, only 2 types of tool wear are there, and there are so many subsections for tool wears, but we have to study only 2 types of wear. The first one is flank wear. See, the flank wear is you can see the figure, the flank surface. If wear is happening on the flank of the machine tool, then that is called as flank wear, and the surface where the wear is formed or worn out region is called as wear land. The second one is crater wear. Crater wear is happened when there are pits. Pits means small holes formed in the tool surface, and the pits is also called as crater. So the next one is crater wear. So you can see the cross section of the tool which has undergone these two wear. Besides these two wears, some wears such as the chipping off of cutting edge and the rounding of tool, like that there are so many tool wears subsections, but you have to study the main parts such as flank wear and crater wear. So I will give a brief introduction in our live classes. Just you have to know that is why it is called as thermal aspects of machining. See, all these conditions here, diffusion wear there is a high temperature condition, and adhesion wear there is a high temperature conditions. You can see it in bold fonts. See, in abrasion wear there is also a high temperature condition, and fatigue wear there is also high temperature condition. Sorry, in fatigue wear there is no high temperature condition. It is just a cause for fatigue wear. And the fifth one, it is itself the wear due to high temperature. And oxidation also. The rate of oxidation increases at high temperature. So you can see the several wear mechanisms comes in the presence of high temperature. So you can say that the main reason for tool wear is high temperature in between tool and workpiece. So that is why it is called as thermal aspects of machining. So we have studied the thermal aspects of machining, different mechanisms of tool wear and types of tool wear. Okay, thank you.